Yeah, so today I'm doing some temper streaming. So temper is a programming language that I work on for my job. It's really nifty. Other than the fact that I get paid to do it, I kind of would do the same thing if I wasn't paid, just like on my own version, right? Because like it's super interesting. Today I wanted to make a little demo and a basic stream for it because I wanted to see like, hey, does temper stream well? Do people receive it well? And I have a mostly technical audience right now, so yeah, that's what I'll be up to. So first, I will initialize a directory for temper. We have our configuration file, which is oh no config found. There we go. And then we have our mandel.temper.me. I'm going to rename this to mandel.temper. So we just have a temper file, and we don't need any of these comments right now. We can just import our config. No, we have to import mandel.temper, right? And now that we have mandel imported, we can build temper. So we can do temper build. And that will build temper to a bunch of different backends. It'll give us a well, it takes a second the first time just because. Uh, ooh, is something wrong? Well, we're gonna find out. Temper. Oh, I know what's wrong. Okay, yes, we have to actually build the current directory. Currently, I was building all the files in my computer. So we just have to get rid of these comments and rebuild. And we will put them side by side just to show you that you can. Translate standard. Uh, okay, so we're gonna have to build for JavaScript and Python right now. I'm on an experimental branch, my personal experimental branch that has fetch support, so like networking stuff. Um, so yeah, active development, under heavy active development. But we get these temper.out files, which we will make a git ignore. Temper.out, and we're gonna add node modules there too, just because, we're doing JavaScript. Okay. So I can run the temper, right, by running with the backend JS, and the temper, we're gonna run our current module, which is Mandel, and our work root being, oop, that was not it. Our work root being the current directory, which is just dot in our case. So yeah, it runs and it doesn't do anything. If we put in here like console.log, it does stuff. And we'll of course need a semi. You will see that, it runs and it does stuff. So what I think we'll do today, and that's why I've named it Mandel, is we're going to Mandelbrot in temper. A very simple Mandelbrot using our float64 data type. It's not going to be super fast, it's not going to be super good, but it will do the job. So, no, let me turn down my volume a little bit. I guess it's peaking, sort of. And let's do minus that many. Okay, dokie. So, first we're going to need to, do a Mandelbrot. So I'm going to look up Mandelbrot algorithms. So let's get over Google Chrome. Let's get this Mandelbrot algorithm. And my cats have decided to come take a visit. Yeah, so this looks like a decent algorithm, doesn't it? I think this looks like a good algorithm. Let's zoom in a little bit to get this in focus. So for each pixel on the screen, x is the scaled coordinate to lie between 2 and 4. Okay, y is. So, okay, I see the first operation being a for each. So let me do like a for var I equals 0, I is less than, and we're just going to do a terminal size. So like 40 pixels, and we're going to call this x. Right, so we're going to do an x and y for loop. Each will be like 40, I guess. Right, so it's just going to be in the terminal for now. Oh, y plus plus, right? And really we should have y outside of x. Yeah, because we're going to do it like this. So we'll have like the let output is a new list builder string. This will be like our, actually, no, let's just do string concats. We're not doing that many anyway. And then console.log output. And then we'll say like let chur equals x and output dot or output equals, and then we'll concatenate. So our concatenation basically, what it does is you just put two string interpolations next to one another. I think this is a nice way to do it. So if we run this, we should get a big bunch of x's and see how big our terminal is in just a second. We don't need the sidebar right now. Yeah, so it's 40 by 40 x's. We could probably do 40 by some smaller number, or just get a little smaller. Um, Probably want a reasonable amount. Yeah, I guess the terminal is, characters are wider than they are tall. So let's do like 10 maybe? I don't know what the right number is. Um, Either way, we've got, yeah, we've got a little grid. Uh, and I'm gonna do like, so scaled x coordinate of pixels, scaled to lie in the Mandelbrot set. So like scale number linear interpolate. Yeah, like we're gonna look at how they do it in oh geez. Yeah, sure. So deinterpolate scale number. Um this looks like a decent one. Scale, let value, interpolate, deinterpolate. You know, we might write our own. Let's write a function. So functions start with let and temper. This is really nice because you can just like let a function. It looks like a function. So like remap, we're gonna call it, and low is a float 64. High is gonna be a float 64. Um, Out, high in, and then low out, float 64. Low in, float 64, right? And we're gonna just kind of clean this up a bit. There we go. And it's gonna return, of course, a function that returns a float 64. So it'll return a function that returns a float 64. And it'll, of course, take a float 64. Make remap. There we go. So this will make a remapper. So like value there. So, and we're gonna do it in two steps. So it returns a remapper, so you can just like put in an argument range and it'll give you back an argument range, which I think is nice. So you just put in the two ranges and you get out a range. So like let scaled throw to 1 is value minus low in divided by high in minus low in. Maybe this will work. So let's say that we got like a value of 10 and the value equals 10, and we have low in equals 5, high in equals 10, right? So what would we do in this case? So we would do 10 minus 5 divided by 10 minus 5. This would get us 1. If we did 5 here, it would be 0 divided by... Yeah, this works. So this is scaled from 0 to 1, and then all we have to do is let remap is going to be scaled 0 to 1 times uh, high... is this out? This should be high out. Yeah, high out minus low out plus low out. Return remap. So this should remap our values. Like I say, let our yf or like word y. Well, let's see, maybe I don't know. I don't know what to call it. And we're gonna say like let map y is going to make remap from 0.0 to 15.0. And what are we mapping it to? 2.0. There we go. Yep. And this really is remap x. And then we're going to have y remap be the same kind of deal, but our y's. So yc will be remap ry. Yeah, sure. Y remap y dot float 64. Right. So actually, yeah, if we like console.log. Oh, 1 second. I have a call coming in. Um. Hmm. Well. Okay. We are back. I shouldn't have stopped the stream really, but hey, um, I think I'm back. Let me just check my audio again. Uh, yup. Okie dokie. So anyway, we got remap of like, and let's start 0.0 dot two string. Right, so this should get us -2, I think. I don't know. Return function something is awry. So return function macro never reached by expander. Huh? Oh, let's just make it single thing then. Value float 64. Let's just do it all at once. That'd be a little lighter on the whatevers. Okay. So we will re yep, yep. Okay. Into that range. Semicolon. And oh, we don't have make remap anymore. Uh-oh. Well, that'll cause problems. That will cause problems, and so will not having a float 64 return type. Yeah, yeah. Okie dokie. -2.0. Perfect. Yeah, and if we say value, let's just make this explicit. And we say value is like 40.0. Um, I probably want some sort of remap class actually. Ooh, that didn't work. So okay. 40 should be scaled 0 to 1 of 1. So we're going to console.log scaled to string because because okay, so it is 1. So we have high out minus low out. So that'll scale it up correctly, plus low out. So if we go remapped, should be correct, but it isn't. It is. Oh no, it is because we're getting out 0.47. I am so silly. Okay, I get it now. I see now. Um, yeah. So remap works. If we like do a class remap, and then we'll do like let public run because you don't need to say let if you have a let like type declaration thing. So we can just pop these in here. And then we'll do like let all these, right? And then we will do like this, because you don't need to use this in temper. That's a really nice thing about temper, is you don't need to use this. So like let x remap rx, sure, new remap, and then we're gonna do 0.40. I don't know, and then -2.0 and 0.47. Yeah, that should work. And then our y is going to be 0 to 15, and then -1.12, 1.1.12. There we go. So, cool. Our x dot run or y, and then we're going to call this like fyf, or chord y. YC. I always have trouble with naming on such things, especially when I'm on Twitch. So, okay, x r x dot x, and then we will be like, okay, we're gonna console.log yc.toString just to be sure. So this should print a bunch of things with a bunch of lines of x's between them. Well, not if I do that. So we've got issues. What are our issues? No member run in remap 2. Ooh, public run. So there's something wrong with our run method. Because I used a comma and that made it a list. Oh, I'm being silly. Lol. Okay. So, and then all we need to do is take our value parameter and put it back. Yo, yep, hello cat. Our value parameter has come back. So now we see it goes all the way up to and down to negative 1.2 and up to 1.12. So now we have our remapped values. Perfect, perfect, perfect. So now we've got x0 and y0, and I guess we could call them x0 and y0. Okay, cool. So next step is x is going to be let x equals 0.0, let y equals 0.0. I'm going to just add y's to these for like index, because yeah, I've got a lot of x's and y's going on right now. So like for var iteration equals 0, I is less than max iters, and then just count up our iterations. And then let's do like let max iters be like 10 or 100. 20. There we go. So we're gonna say let x temp is x times x minus y times y. I don't know what any of this does, but it works. So oh, x has to be mutable, so we have to make vars, because in temper, let is like kind of like JavaScript's const, where it's const, and var is kind of like let, where it's scoped. We thought just shift them over by one, so that you can, you know, um, so that you can. It's just nicer. Users don't need. I'm gonna say that you can pre-declare things, so do that. Xtemp, yep, and then we're gonna say iteration. Oh, we've already done that because we've written a for loop. And then palette is color iteration. So I'm gonna say like our chur is going to be uh, and it okay. So while iterations, but we also have to do this. So we'll do x times x plus y times y, and I think this is just comparing 4. So then we're going to do char, and if is an expression in temper. This is a really cool thing. We can do if x. Then let's do this. If and then like iteration is equal to max iters, right? We should probably extract you. You know, it should have been a while all along. Oh, I've been bamboozled. Um, and I don't like using plus plus, even though you can in a statement. I generally just prefer plus equals when it's not like for loop or in an expression. Yeah. So then we go if char is max iteration, we'll do a hash for that, and then a space maybe? Sure. Because block values just return by not having a semicolon. It's really nice. 2 is x times y. Yeah, 2.0, 4.0. It's kind of like OpenGL in that like you can't do like you can't like mix ints and floats. This makes it really nice on the back ends though, like on like JavaScript. Because look, little Mandelbrot, little teeny tiny Mandelbrot. We did like 0.0 and 0.0 and like our x dot and then high Alright, so low in, yeah, and then we'll do the same for Y. Okay, so low in and high in. Okay, so now we can make bigger Mandelbrots just by kind of by changing our remaps, except I didn't do it right. Because I have to use plus equals, because plus plus is an integer operation. Even in like C and stuff like that, it is. Y of xi. And we don't need these two float 64s anymore. Woohoo! 0, y 0. Perfect. Let's see if this works. Well, no. And you always have to look at the first error because I'm in like the mode where you have to do that. Oh yeah, let public. Because let is by default private. Temper is private by default. This is nice when you're like trying to um when you're trying to keep your data from like getting used and your APIs from getting messed up. Like people will just use an API without knowing that they can use it. It's kind of a mess. And I comma again. I keep commaing myself. I need to stop this. I really need to use semicolons. Okay, Mandelbrot is back. So cool. If we hit full screen, make it big, and change our values so that it's like instead of 15, we're gonna do like 30, and we're gonna do like 80. Yeah, yeah. Let's see this. Ooh, it's coming along. Right? Cool. Cool. So it prints out a Mandelbrot set from JavaScript. It writes some JavaScript code. The temper compiles into this index.js import Mandel. Mandel is a library node modules, right? It has an index.js, mandel.js, comes through temper core and just implements our cores in JavaScript. This is a neat thing about temper. It compiles to like whatever you want, and yeah, that's a really cool thing about temper. Also, could compile to Python. I think Python's working on my branch. Because of, come on, it's taken a second, but yeah, it runs on Python and it writes an equivalent Python program for us. So like, yeah, this was just me testing out Streamin' too. Like it's type Python fully, but like you can MyPyC it, you can make it run really fast, you can make it run really slow. It's Python, you can do whatever you want with it. It tries to type your Python, so even like things like this, like it knows the type of everything, which is really cool, even locals. So you can run it through MyPyC, which compiles Python to C. If we look at MyPyC, it is an annotated Python to C modularizations compiler. It uses standard Python type hints to generate fast code. It's really good. It's kind of like Python 3, like the Python mode, but also it just temper generates it. So you can write temper code, and that temper code will work with it. So if anyone has any questions, feel free to ask. Otherwise, I'm just gonna say, you know what, we've had enough stream for right now, because, you know, yeah. But this was my first temper stream. I thought I'd do some streaming with temper. I think it went well. I don't know many people watch, but I think it went well. But yeah, yeah, this is some temper code. I will put this out on GitHub fairly soon and link it. Feel free to join the temper Discord server if you see it in my. Well, I don't remember where you can find it, but you can find it somewhere on my profile. Temper Code under About Me. Yeah, I'm still new to Twitch, but if you want to join and ping Shaw Suma, I'm Shaw Suma. You can ping me and say, "Hey, I found you from Twitch, and we're looking for people to start in Temper because it's getting out there." And it works with Python, JavaScript, C Sharp, Java, and Lua. We're working on Rust, and hey, if need, we can work on a Nulet backend for anyone if they, need it or want to have a use case for it. So yeah, yeah, that's about all I got. Anyway, y'all, nice day, and that's the end of the stream. Thank you. Oh, and YouTube, have a nice day too.